Ophthalmic diseases affect hundreds of millions of patients worldwide, while significant unmet medical needs remain in conditions such as dry AMD, uveitis, and dry eye disease. Existing treatments still face challenges in balancing efficacy, safety, patient adherence, and drug delivery.
Hi everybody, Alex Javrenkov here, CEO of In Silico Medicine. Today is a very special day because we are announcing the developmental candidate nomination for Target Y. The reason why it's called Target Y is because we are not disclosing the target name.
Against this background of unmet medical need, In Silico Medicine nominated ISM9077, an AI-enabled Target Y inhibitor, and a potential first-in-class preclinical candidate.
So when we started working on this target, we applied our platform called PandaOmics that allows you to rank targets, certain diseases, and create those very strong and high confidence disease target associations. So we've implicated this target in multiple ocular diseases strongly, but also in many other age-related diseases.
Target Y has biological links to inflammation, ophthalmic diseases, and age-related conditions. Because the efficacy evidence in ophthalmic models was the clearest, the team chose ophthalmology as the initial development direction.
So we did not expect this kind of strong efficacy in early-stage preclinical experiments, and decided to make a pretty significant bet on this program completely from scratch with maximally multi-parameter optimized with many different properties.
Preclinical studies showed that ISM9077 produced encouraging efficacy in disease models of dry AMD, uveitis, and dry eye disease.
So we started working on a novel molecule completely from scratch with maximally a multi-parameter optimized structure with many different properties that allow it to make the molecule into a great drug.
With the support of AI-driven target discovery, molecular generation, and structural optimization, the team designed and selected ISM9077 from scratch. The process required balancing activity, potency, safety, pharmacokinetics, and drug delivery.
Target Y is a challenging target. Many companies were chasing after that targets for many years, but it's really challenging to identify a good molecule with balanced profile and the potency in the preclinical studies. So for now, in silico medicine, by leveraging our chemistry for D2, ideally we can deliver a drug potential be used for eye drop and oral, and our molecule can achieve the both.
For an ophthalmic drug, efficacy is only the first step. The molecule must reach the posterior part of the eye, achieve sufficient tissue exposure, and balance pharmacokinetics with safety.
I would say it's very promising data. So it's kind of like our general practice. We always do the head-to-head comparison in our studies, not only for the efficacy, but also for the toxicities. We want to make sure our molecule shows the best potential. So, for now, we didn't disclose the target, but I can disclose that the molecule is very safe with large therapeutic window. All the in vivo toxicity studies.
Our developmental candidate standard is 2 species, 28-day non-GLP tox. Here we did 3 species. So we did rat, rabbit, and monkey, 28-day DRFs. So here, one other quite quick note about this program is that we've patented many other molecules for this indication. So this target has not been associated with multiple ocular diseases before, especially dry AMD.
ISM9077 is the 32nd preclinical candidate nominated by In Silico Medicine since 2021, and 13 of those candidates have received IND clearance. It reflects the scalability and continuous output of AI-enabled early-stage drug development.
I am very pleased to say that this target is also very implicated on aging and age-related diseases. As you know, In Silico is committed to extending healthy, productive longevity for everybody on the planet.
Ophthalmology is the clearest development focus for ISM9077 at this stage. At the same time, the biological links between Target Y, aging, and multiple age-related diseases create further room for research into healthy longevity and interventions in aging biology. This reflects in silico medicine's dual-purpose development logic.
I would say we are very open-minded, right? Well, we will definitely open to some like in-depth discussion with the potential partner, but we are not that hurried to license out this molecule. We do have a very high confidence in this asset. We are okay to develop this program further by ourselves. But again, so, it's always helpful to have those kind of in-depth discussion with the expertise, especially the one who's working in this area for decades, for a long time.
From unmet needs in ophthalmology to a potential first-in-class target Y inhibitor, and from preclinical efficacy to tissue exposure and drug delivery validation, ISM9077 illustrates an AI-enabled path for early-stage drug development and opens a new direction for understanding the links between disease and aging.